Okay, so f of x became h of x, right? So the instructions on the previous page follow. The graphs of y equals f of x and y equals h of x are shown. If h of x is a transformed image of f of x, write the equation of h of x in terms of f of x in simplified form. So we need to figure out what's going on, right? And we have 6 possible transformations. A horizontal stretch, a vertical stretch, reflection in the y-axis, reflection in the x-axis, a horizontal translation, and a vertical translation. This is what we're starting with, so just be aware I'm going from this to this. Okay, so it doesn't look as high. How high is the new one? It's like a half of something too, right? How high is the original one? Well, it goes 2 to 5, so it must be 3 units high. How high is the new one? You can use words like it's 1/4 the height of the original, it's 3 times the height of the original, it's 17 times. Okay, vertical stretch by a factor of what? 1/2. So, but we should say about what axis, right? So we've got a vertical stretch about the x-axis, vs, about x-axis, by a factor of 1/2. Oh, horizontally, this, I'm just going to count this like, you know, we're back in preschool even. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, give me some words to go with that. There's a horizontal stretch about the y-axis by a factor of 3. Okay, having done all of that, we now need to figure out, are there any reflections? So, is there a reflection about the x-axis? No, right? We got a long horizontal line here, we got a long horizontal line. That would be down below if there was reflected this way. But this points right, at least to me, this is going to the right, and this guy's left, so then what else is going? A reflection about the y-axis. Okay, and after all that happens, then maybe something moves. How are we going to figure that out? So what we could do is sketch all of the intermediate steps, or we could just try and get there in one move. So which do you prefer? One move? Okay. So all we got to do is let's identify a point, this guy, and where does it end up? It ends up there, right? So what we're going to do is we've got the words, at least that get us to the reflection, and then we're just going to say, now we need to move you into position, right? So I'm going to vertically stretch by a factor of 1/2. So instead of 5, it's going to be how high? 2.5. I am then going to, actually you figure it out. You're not going to do any work on your own, so you might as well do some work on your own. I want you to come up with 2 things, a horizontal translation, a vertical translation, check with the people around you, and see if you can come to an agreement, right? And then come to a agreement. I'm going to just pause this so we don't have to. Okay, so I get a horizontal translation, which way? Right, how much? Right, 12. And I get a vertical translation down. Okay, so let's call that 9/2 just because fractions are nicer. They're more exact. Okay, so how did we get there? I'm going to do a vertical stretch by a factor of 1/2, so this point will now be at 5 and 2.5. I'm going to horizontally stretch it by a factor of 3. It's going to move up to 15, 2.5. I'm going to reflect it about the y-axis. It is now at negative 15. 2.5. I need to move from negative 15 to negative 3. That's going to be right 12. I need to move from 2.5 down to negative 2. So I'm going to go down 2.5 and then down another 2, which is down 4.5, which we convert to 9/2. There we are. Okay, and then I'm going to follow the rest of the directions, which is I'm now just going to take that and I'm going to write it out transformation form. So here, you can squeeze that in here. So we started with y equals f of x. Vertical stretch. I'm not going to ask you guys anymore. I'm just going to write them down, okay? And then you can say, hey, you wrote the wrong thing down. So vertical stretch about the x-axis. So I need to be thinking that I'm going to replace y with 2y. So 2y is equal to f of x. Horizontal stretch by a factor of 3. So 2y is equal to f of 1/3 x. Reflection about the y-axis, so 2y is equal to f of negative 1/3 x. Now I really replaced x with negative x, but I'm going to write the negative in front of the 1/3. Right 12, so now I got 2. I'm going to do these two together actually, right? Because one is on y and one is on x, so I don't have to. So it's going to be 2 down, so plus 9/2 is equal to f of negative 1/3, and I'm going to replace x with x minus 12. And close off that parenthesis as well. And the form we wanted was more of a standard form, so it's kind of got to be y equals. So it's going to be y equals. So I'm going to take the 2 out, so it's going to be y is equal to 1/2 f, square bracket, negative 1/3 x minus 12. And then the plus 9/2 is going to become a minus 9/2. Okay, so that's y, and then ultimately we're going to write that as h of x equals. So the final step, square bracket, sorry. Minus 9. Okay? Yep. I don't know, are we allowed to? What form did it ask for? It said, instructions, previous page. Simplified form. Now you flip back another page. Simplified form, bx minus u. So as a matter of fact, I am supposed to do that, right? So as a matter of fact, you're right. So we are supposed to distribute this. So it'll be h of x equals 1/2 f of negative 1/3 x something minus 9/2. What's the something? Plus 4. And that is my answer. Okay. Now, generally, on the test, we'll say in the form, and we'll show you the form we want, so that you'll know. There won't be any question about, which, not expecting you to remember the simplified form, the transform form, this is the indeterminate. We didn't name it in the book form, right? So, because we can't do that. If they didn't name it, we can't know. Okay. I'm going to leave that one for you to not do at home. The answer is on here. If you do it at home and want to check it. Okay? So this is for you to do. Here is an identifiable point, and here is where the identifiable point ended up, right? So we have to do that with something that's symmetric, right?
Yeah, you got it.
Oh, here is the identifiable point. See? I do the same thing, right? So, I would have got that wrong, because I would have gone the other order. We would have had a nice multiple choice answer waiting for you, which was you going from here to here. So thank you for pointing that out. It's very easy to do, right? Mostly because I go left to right. So here's the identifiable point. You need one on a quadratic, right? Because it's symmetric. So if that was a solid dot and that was a solid dot, you would actually have options, right? Because you could say, well, I could have reflected it that way, right? Or, now in this case, there is no or, right? It had to be, you have to have this. That will be in the same orientation, so then it's just translate, right? It is not this. This is not happening. I'm waving my hand in the air if you're just listening to this online, but there's no reflection over the y-axis. Otherwise, this would be on the left-hand side of the transform, right? So you got to look for that. If these are both solid dots, we could say, give me two possibilities. And you could, well, okay, so you can do this. You can reflect it in the y-axis. That would change how much you translate. If you don't reflect it in the y-axis, that would give you a different translation. You would still end up with, as far as you know, the same thing. Okay. 11. 11, yes, says to do this one. The function y equals f of x is transformed such that the point, so now we're going from a point and we're getting an image point, right, the mapping. And so this gives us a chance to try our wordy descriptions of what's going on when I have an image point, as opposed to what's going on when I've just got the formula. Okay, so write the equation of the transform function in this form, and we're very nice, we gave you the form. So let us take xy, and one at a time, we're going to do some transformations, and we're going to end up with negative x plus 1, 3y minus 2. Okay? And I'm actually going to make this a slightly bigger arrow so I can actually write below that arrow what happens. So, what's the first transformation that we do? Okay, so first, that wasn't the answer to the question. Well, okay, sort of it was, right? The first thing we look for is stretches, right? Sorry, that's what I meant. So stretches, is there a stretch? Yes, what is a vertical stretch by 3? Okay, now I'm going to go, I'm just going to say Vs by 3. I'm not going to say about V because it's not a lot of room. Okay. So then xy becomes what? So we got an x3y, right? Okay, good. Took care of the 3. Now, stretches are followed by what type of general transformation? Reflections. Is there a reflection?
Yes.
Where? Or how? Reflect about y-axis. Okay, like if I say vertical stretch by 3, it has to be about the x-axis, right? So I can get away with not saying that, just in this little limited space, but I can't say reflect in general because you do have to say where. So now what do I write? Negative x, so x is replaced with negative x. I get negative x and 3y, and let's do these two together because one's on the x and one's on the y. So then I've got a ht, right, 1, and I've got a vt down 2, and that gives me negative x plus 1, 3y minus 2. Okay, so I have taken the image point through a series of transformations to what it's supposed to be, right? What we end up with. And now I want to write the equation. So to do the equation, I'm just going to take these words, and we're going to start with y equals f of x, and just run through what we've been doing. Well, okay, so you should be able to do this now. Go ahead, do it. I will hit pause again. Okay, you've had your shot. What's going on here? We have a vertical stretch by 3, so what do I write? 1/3 y is equal to f of x. Okay. I'm trying to keep this simple, right? It's just, if I say vertical stretch by 3, you just say if I see a y, I'm going to write 1/3 y. Reflect about the x-axis. What am I going to write? I see an x, I replace it with negative x. That is a reflection about the x-axis. Go right. Okay, well, we're going to go down 2. What do I do? What do I next write?
1/3
bracket y plus 2 is equal to f of negative bracket. Yeah? Okay. But there's a negative in front of the x. Who cares? If I replace an x with an x minus 1, what happens? It moves right 1. Am I in the form that we want it to be? Not yet. So I need to get rid of that 1/3. Okay, so how am I going to do that? I'm going to multiply by 3. So I'm going to get y plus 2. Right? I can remove the brackets now around the y because I'm multiplying both sides by 3. Is equal to 3 f square bracket. Now, do I want to write negative x plus 1? No, I need the b value in front. So negative bracket x minus 1. But no buts. That's it, right? That's in the form. Y plus k, sorry, y minus k is equal to. So, here's how you check this stuff over, right? You get somebody else, you hide everything, so you cover everything up, you give this to a person, and you say, tell me what's going on. So all of you should be able to look at that and say, so I'm ignoring everything up here, but as I do this, you should be seeing the words up here, right? There is a vertical stretch by a factor of 3 about the whatever axis we use, the x-axis. there's a reflection about the y-axis, and then it is moved right 1 and up 2. Down 2. Sorry, down 2. Okay, so there's your word. Vertex stretched by 3, reflection, right 1 down. Okay. And if that matches up, then it's all good. Okay, 12, very similar. Not as dramatic when it doesn't actually move. 13. Okay, give it a shot. I'm going to give you some time. Okay, so before we move on, let's just talk about the stretches, okay? So, this is the transform. So something has been changed so that its domain is now 0 to 5 and its range is now negative 10 to 8. This is the original, and this is its domain and range. So its domain is negative 6 to 4, which covers 10 units. And now it covers 5 units, so there is a horizontal stretch about the y-axis by a factor of 1/2. Okay, the original goes from negative 4 to 2, so the original range covers 6 units. The new range goes from negative 10 to 8, which is 18 units. So there is a vertical stretch about the x-axis by a factor of 3. Okay. Follow that, and then figure out how you're going to get the thing up to where it's supposed to be, right? So to follow that, I'm going to pick this point, especially, or I could pick one of these guys here. This one's a little worse to pick because it won't be on the extreme, right? Like we know this is the highest it gets, and we don't know if there's reflections, same or reflect. No, using 2 stretches and 2 translations only, right? Okay, so no reflections. We got the 2 stretches. Okay, so I'm going to take this, and what do we say? A horizontal stretch by 1/2, so negative 6 moves to negative 3. Vertically stretched by a factor of 3, so now it's up here. Okay, and so that means that it's here, but my domain is 0 to 5, so I'm going to have to move this over to 0. And my range is negative 10 to 8, so I'm going to have to move that too. So what are we doing? 1, 2, 3, and 1, 2. So horizontal translation, right 3, and a vertical translation, up 2. Now, I'm not entirely sure that that's necessarily it, so then what I'll do is take this point and run it through these guys and see if it ends up. So this should end up at the extreme of the domain, right? It's at 4, so this should end up at 8 if I do all of that stuff to it. It is not at the highest or lowest, though, so that just verifies my domain. To verify the range, I can take this point and just make sure that it ends up at the bottom of the range, at negative 10. If that's true, then I know these are correct. Okay? And then all we're doing is translating from words into the equation. Okay. And I'll let you do the equation. We've done enough equation stuff now, right? That you should be able to do the equation stuff. Okay, so write the equation. That's on you. All together now. Okay, just put it all together. So in that case, what we're looking at is, instead of giving you the 2 graphs and having you count it, oh look, this covers 5 units and this covers 10 units, so it must be stretched by a factor of 2. We gave you a domain, right? And we said, okay, well, here's a graph. Figure out the domain and range from the graph, and then here's the new domain. How did that happen? This was 10, this is 5. Oh, that's a half. This was this was that. Oh, that's a... Okay. If the domain and range, so now here's another one. Then determine the domain and range. All right, so what should you do? figure out the transformations, right? Which you will verbally describe. Well, actually, you'll write them down. Okay, so what you want to do is just go through this. You can rearrange it if you like or not. So you could just look at that and say it's this and this and this and this and this, right? Or you can rearrange it and say it's a this, a this, a this, a this, and a this. Okay, so whichever you like. Come up with a description in words. Okay, so I'm just going to start. Okay, let's just do that. I'm going to go y is equal to negative 1/2 f 1/3. Okay, and then I'm going to make that a negative 2. Now it's going to come over to negative 2. And then I'm going to have to subtract a 5. Negative 2y minus 5. Actually, that would happen first, right? So I'd move the 5 over. So now I got y minus 5 multiplied by negative 2. Negative 2y minus 5. Okay, so we could do that if you like. And now you're going to list your stretches and your reflections. Leave some space. So do that here. So list your stuff here. Leave some room here. We'll write our domains and ranges, right? So as we do stuff, we will then change domain and range to match what it is we say we're doing. Okay, so come up with a written description in the correct order of the transformations, and then what we'll do is together we'll just work our way through the domain and range doing exactly that, right? Unless you're good and then just do it yourself and then compare. So what do we got? Number 2. Number 3. Number 4. Okay, excuse me. So we look at the transformation form and now we put it into words, right? So they say, oh, x replaced by 1/3 x. It's a horizontal stretch about the whatever line it is. We stretch that about the line x equals 0 or the y-axis by a factor of 3. We have a vertical stretch by a factor of 1/2. We're reflecting about the x-axis. We're moving right 1 and not 5. So horizontal stretch, does that affect the domain or the range? Okay, so my new domain is the set of all x such that, what's my new domain? Negative 3 times 3? Oh, no. One step at a time. Yeah, your final answer. I'm going one step at a time here, right? So negative what? Negative 9 less than or equal to x less than or equal to 3. Okay. Any questions? Right? We're stretching by a factor of 3, then everything's going to triple, right? Okay, vertical stretch. Does that affect domain or range or both or neither? Range. Okay, y such that y, what about y now? Less than or equal to 1. Okay. Reflection about the x-axis. Does that affect domain or range? Range. Okay, what's the new range? Okay, there's negative 1, but there's a sign in between the y and the negative 1. Okay, pretend it's a parabola, right? So we have this parabola, and originally it's opening which way? Y is less than or equal to 2. It's got to be going down. Okay. So if we stretch it, now it's y is less than or equal to 1. When we reflect it, greater than or equal to negative 1. Okay, so the 1 becomes a negative 1, right? We just know that. If I take that point at 1, it's got to go to negative 1. But this thing that apparently was opening down is now opening up. So it's greater than or equal to negative 1. And then we move it right 1 and down 5. So actually here, let's sort of separate these. That's separate. That's separate. Because what I write here is now going to be my new domain and range, right? Like the final. So what's my new domain? Set of all x such that, go ahead, negative 8, less than or equal to x, less than or equal to? We're not going to move it. You're going to move one end, but not the other end? 4. Okay, so you're moving, you're just going to add 1, right? Write 1, add 1. Range, up 5. Make 1, 4. What is that? 14. There we go. It's actually 15 on the same page. Okay, variation. Give it a shot. It's going backwards. 1 for all. Okay, so wordy stuff. We have a vertical stretch by a factor of 1/2 about the x-axis. So this started out as negative 3, 8, and it now becomes negative 3, 4. Then we have, what do we have next? Reflection about the y-axis. So now we're at 3, 4. And then what did we do? We went down 3, so VT down 3, and an HT right 1. And I'm going to do those together. Right. So if I go down, if I go right 1, I'm going to go to 4, and if I go down 3, I'm going to go to 1. Okay, so there it is.
I think it's really necessary to write
One more.
down.
Had to go down. Oh, because I asked that earlier. I said, how far up or down? And somebody said 3. Well, you were thinking 6, and I said, 3 is right, but you were thinking 6. You got to do this.
Yeah, you
have to.
Better to have the.
Okay. Look, you guys are look. Some of you guys are gonna look at this and
You
say,
have the-
down 6. You can't fool me. Plus is down. I know that. Yeah, it's not down 6.
But
Right?
actually,
Up or down, left or right is read off of an isolated, only on the x, I'm doing something, right? X was replaced with x minus 1 is a horizontal translation, right 1. What do you say here? Like 2y was replaced by 2y plus 6? No. You say y was replaced by 2y. And then the y was replaced by y plus 3, so that I ended up with 2y plus 6 if I expand it. But if I want to read this, it has to be parenthesis y plus or minus number. 16. Okay, if at first you didn't succeed, try again. So do this one. I need to give you like a 30-second head start, and I'm just going to start writing down what I've got, and you can start looking up and saying, okay. But what do we do? What are you going to do? You're going to describe, is this up 5 or down 5? Don't say yes, because it is one or the other. Which one is it? Up 5 or down 5?
Up 5.
Up 5. Why? Because you have to do this. Okay?
What do they mean?
You got to do that. You actually need to write that down, so when you look at it, you don't just sit there and say, oh, is it plus 5? I'm going to go down 5. No, you're not. Okay, somebody had a question. I don't know. I thought I saw a hand up. what am I doing? Image point. So that's what I'm starting with. Okay, what's going on? Yeah. So if you like, you can start by just doing all of your descriptions first, right? And then you can do operate on the point. Oh, is something wrong? Or should it be?
-4 + 5.
Well, no. The line I wrote should be 4x comma negative y. No. I gotta go left 2 and up 5. That's the final answer. The correct one, the corrected. See, I did that one on purpose, right? That's why I didn't go on and write it, because then I'd just have to go back and erase the whole pile of stuff. Okay? "17. Enjoy your weekend." You're doing all of 17. 17 is kind of putting it all together. You need to do this before the test. You must do and understand 17 fully. If you do not, the management will take no responsibility for how you do on the actual test on Wednesday. Okay? So you have until Wednesday to do. You should do all of 5 and all the other ones that we have not done, but 17 kind of puts everything together. So you got to be able to work your way through it, check the answer, and then if you're not getting it, phone a friend on the weekend. Come over, I need help with that. Right? It is? I thought we moved it to Wednesday. But yeah, no, they moved the fire drill, so yes. That's what we said. Oh, really? Okay.
So are we ready on
Yes. Yeah, well, I didn't say which one. It just said Tuesday or Wednesday. We are writing it on Tuesday or Wednesday. The question was asked, are we writing it on Tuesday or Wednesday? And the answer was yes. At which point you shake your head and say, I now am no further ahead than I was 30 seconds ago, except I do know it's on one of those 2 days. The follow-up question is which one, and the answer is Wednesday. Okay? So we are writing the test on Wednesday. So here's an equation. From the equation, we state the... Now you load up. What might I want to write in here? X minus 4, right? I might want to write that, but this will just leap to the next thing. Okay. So we got that. We need the equation for g of x in terms of f of x. The transformation, so we know here's how we're going to get from f of x to g of x, right? Now we're not just doing this on some general f of x. We have a specific f of x, right? So, okay, what do we got here? We are doing equation for g of x in terms of, in the form g of x equals. Okay, so we're just going to start with y equals. So y is equal to, okay, wait, oh, sorry, this is in terms, so just y equals f of x. So we're just going to do the general transformations on f of x, right? And then here, we'll do the specific transformations on the actual equation. Okay. What do we got? Horizontal stretch by a half and a vertical stretch by a half. I could do those on the same line because one is on y and one is on x. So it's going to be 2y is equal to f of 2x. Left 3 and down 1, okay, I can just do those again. So down 1, 2 bracket y plus or minus? Plus 1 is equal to f of 2 bracket x plus 3. Okay, and now we need g of x. Well, what I could do is isolate the y. So let's multiply both sides by a half. So y plus 1, well, we could do the minus 1 afterwards. So y is equal to 1/2 f of, let's expand this out, because no, that's not, that's for that, 2 bracket x plus 3, bracket, and then that would have been y plus 1, I'm going to move the 1 over to be minus 1. Okay, but we want g of x, 1/2 f of 2 x plus 3 minus 1. Okay. Write the equation for g of x in terms of x, simplified and written as g of x. So now in terms of x, this one's written in terms of x. Actually, I'm going to take that out of there. Okay. So what we want to do now is, same deal, right? But now we're going to say, well, let's start with y. So write this as y is equal to the square root of 2x minus 8. So horizontal stretch by a half, y becomes 2y. So 2y is equal to the square root. Now, how do I do a vertical stretch by a half? Or sorry, that was a vertical stretch by a half. How do I do a horizontal stretch by a half? Where I see x, what do I write? 2x. So now this becomes 2, and then what? 2x, and then the minus 8. Okay. Now what? So, now left 3 and down 1. So let's do the down 1. 2 bracket, where I see y, I write y plus 1. It's equal to the root of, okay, that's a 4. Let's just call it a 4. Okay, now what do I write? X plus 3. Okay, I want to move left 3. Where I see an x, I write x plus 3. And then we got the minus 8. Okay, now we're going to clean stuff up. So 2y plus 1, well, actually,
Let's do it again.
yeah,
So you went from 2 times 2x minus
which is
8.
4x.
Yeah, 4x. So you don't, it's not 2x plus 3 brackets, it's 4.
You could go 2 times, okay, which is ultimately going to end up being 4x plus 12, which is 4x plus 1. Okay. But yeah, you could do this, but 2 times 2 is 4 at the x, right? You can sort of simplify a bit along the way. So we want g of x equal to, we have to isolate this. Let's just do this. Let's clean up in the brackets. So this is going to be 4x plus 12 minus 8, which is equal to 4x plus 12 minus 8 is plus 4. 4x plus 4. Okay, now we need to isolate this and write it as y equals so that we can then write it as g of x equals. So we're going to move over the 2. So we're going to multiply by a half. Y plus 1 is 1/2 of this 4x plus 4. So y is equal to 1/2 4x plus 4 minus 1. Okay, so then g of x equals oh, well, we got 4x plus 4, so what's that? Yep.
Just have a question. Can you start writing it as g of x?
Yes. Yeah, you can start writing g of x. it's way too many pen strokes. I just do y equals and at the end I say, it wasn't supposed to be y, it was supposed to be p vax. But yeah, you can start writing p vax. Yep. Okay, watch. So y is 1/2 root. I'm going to go through way too many steps here. Yep.
It asked for it in simplified form.
Yep.
Oh, yeah, sorry, that was my bad, one moment.
It's okay. Here's way too many steps. What's this? 2. What's 1/2 times 2? And it's supposed to be g of x. Okay. Did I ever say welcome to Math 30-1? Welcome to Math 30-1. All right, we're going to start in inverses. So if you didn't get it written down, you know where it's written down. You can go look for it. Inverse of a relation. Relation, a statement that relates two or more variables. Relation, a relation between two variables can be described mathematically with a or n. So a set of ordered pairs is a relation. You can graph those ordered pairs or draw a graph. So a graph is another way to describe a relation. And an equation, x squared plus y squared equals 1, which is the equation of this. And these are simply points that are actually on there. But come on, go forward. Relations is function. What makes a relation a function? We know this from 10c, right? In a relation, if each domain value is paired with only one range value, the relation is a function. If a domain value is paired with two or more range values, then it is not a function. So label as function or not. So yes, function or no? Function or no? Function or no? Function or no? Well, that x value has two different y values, right? So not a function. Inverse of a relation. The inverse of a relation results when the two variables of the relation are interchanged. If y equals f of x, then the inverse becomes x equals f of y. We are going to be doing a lot of inverse of functions, right, or relations. Example 1, a set of ordered pairs. A relation is described by the set of ordered pairs 2, 3, 4, 1, negative 5. What is the domain and range? So the domain is the x values. It is the set of numbers. Well, we could list them in order if we like. 1, 2, 3. And the range is the set of numbers negative 5, 3, 4. The inverse of a relation is described by the set of ordered pairs. So what do I get if I take the inverse of this relation? I interchange x and y. We get 3, 2, 4, 3, negative 5, 1. What are the domain and range of the inverse? So the domain is negative 5, 3, 4, which kind of looks suspiciously like that. And the range is, the y value is 1, 2, 3, which kind of looks suspiciously like that. So how do the domain and range of the original relation compare to the domain and range of its inverse? They're interchanged, right? So the domain of the original is the range of the inverse. Okay, domain of original is range of inverse. And the range of the original is the domain of the inverse. Is domain of inverse, is the domain of the inverse. Right, and why? Because, well, you're just interchanging x and y. The x values are the domain, the y values are the range. If you interchange them, you interchange the domain and the range. A linear relation is described by the equation y equals 2x plus 4. The inverse is described by x is equal to 2y plus 4. Okay, so again, you interchange x and y. However, equations of relations and functions should be expressed in the form y equals if possible. So then this is going to become x minus 4 is x minus 4 is equal to 2y, which becomes y is equal to x minus 4 over 2. And then, of course, we should cancel this, right? Get that. Equals x minus 2, right?
You missed blank.
Yep.
Did I miss? What did I miss?
Is it y?
It's
Oh, y equals, yeah, x. Okay, so here we go. Good? Yeah, you're right. You can't do that. Don't do that. Not possible. Okay, that's it. You cannot cancel it. It has to be a common factor of the top and the bottom. Right? If there was a 2 bracket on the top and a 2 on the bottom, then yes, I can cancel that. Right? Another way to write this would be, of course, y equals 1/2 x minus 4. Right? That's a little more transformation-y, right? Really, a transformation happened here, right? This is like 2y, right? It's vertically stretched by a factor of half, and it's moved right forward. And the original was horizontally stretched by a factor of half, and we're not getting into that just that. Complete the table of values and graph the relation and its inverse on the grid below. Maybe we can get away with it. Yeah, real soon now. 2x plus 4, 2 times negative 3 is negative 6, plus 4 is negative 2, 2 times negative 2 is negative 4, plus 4 is 0, negative 2 plus 4 is 2. 0 plus that is 4, that's 6, that's 8, and that's 10. And if this is the inverse, I'm not going to work out values, I'm just going to interchange them, right? So this is negative 2, negative 3, this is 0, negative 2, 2, negative 1, 4, 0, 6, 1, 8, 2, 10, 3. Should have used a different color, I guess. You can graph the original in red, negative 3, negative 2, negative 2, 0, 1, 2, sorry, negative 1, 2, negative 1, 2, 0, 4, 1, 6, 2, 8, 3, 10. And we'll do the inverse in green, so that's negative, yeah, I knew that.